today's Friday Math Happy Hour. Today's topics, we're going to cover sets and probabilities. I believe permutations and combinations will be next week. Okay. I should have corrected this, but today's topics are just sets and basic probabilities. Okay. Now, before we begin, we have to define some of the definitions here for this section. Okay. For example, a set is a well-defined collection of objects, such as examples of sets. Well-defined collection of objects, for example, all the students in my math class. That's a well-defined collection of objects. The letters in the alphabet, that's also well-defined. Here's an example of something that's not well-defined, a set that's not well-defined. The collection of young adults. You see, that's not well-defined because young adults can be what? What age groups are considered young adults? That's why this is not a set. Now, how can we fix this one? Now, by saying the collection of young adults between the ages of 18 and to 29, now that's well defined. Just by adding between the ages of 18 to 29 makes it a set. Okay? Now, capital letters such as A, B, and C, and so forth are used to name sets. Each object in the set is called a member or element of the set. Example. But let me example, the set of braces are used to enclose objects in a set. Here we go. This is the example. This means set A is equal to the elements 3, 4, and 5. This symbol here, guys, like a knee, means it's an element of the set, or it belongs in the set. And this symbol with a cross over it, the same symbol, it means it's not an element of the set or does not belong in the set. Example, okay, this is set A is equal to 3, 4, 5. Now, this is a true statement, right? Because 3 is an element of set A, because 3 is in the set of A. Or 3 is a element of the set 3, 4, 5. These are the same thing. Okay, so that's what the symbol means. And here's how you say it, right? In words. 3 is an element of set A, or 3 is an element of the set containing 3, 4, and 5. Now, this is also a true statement. 2 is not an element of set A, right? Or 2 is not in A. That's what that means, right? So anyway, or 2 is not an element of the set containing 3, 4, and 5. And here's the correct word. Here's how you read it. 2 is not an element of the set A, or 2 is not an element of the set containing 3, 4, and 5. Okay, definition and examples. Empty set. An empty set is a set with no elements. These are the two symbols of empty set. Okay, now I know this material here is something that perhaps you haven't been you haven't been exposed to it yet. So at times it's wise to write all the definitions and all the meanings in an index card. When I was taking this course back in 2005, something like that, I had like a difficult time, and the instructor told me to what I just mentioned to you guys to actually put them in index cards. Okay, and this way I was able to do the homework and understand the material. Okay, because if you just blow it off, you know what I'm saying, when you do your homework and if you don't write them down somewhere, you're not going to know what they're asking for. Okay, so in my opinion, it's a good it's a good way to do your math. Now, equal sets. Equal sets are sets containing exactly the same elements. For example, the set 3, 4, 5 is equal to the set 5, 4, 3, or is equal to the set 4, 3, 5. You see, this set contains 3 elements, and now the elements are the same, 3, 4, and 5, in different order. So these are considered equal sets. Now, sometimes we describe a set by common property of its elements rather than by a list of its elements. Up to this point, we've done a list of its elements. Now we can describe it by using the set builder notation. let me explain what it means. Okay, this is what it means here, guys. Okay, this is how you read it. The set of all elements X such that X has a property of P. I mean, whatever the property of P, guys, that's what X has. Okay, I'm going to break it down here. The set, right, means the brackets of all elements X is the X right there after the bracket. The line, the vertical line means such that. And here's a property. X has a property of whatever P is. Okay, that's breaking it down to the extreme. Now, example. List the elements in the given set. Okay, the set of all elements X such that X is a natural number more than 5 and less than 8. So before we continue, you have to know what natural numbers are. Okay, but natural numbers are also counting numbers, which are equal to every number from 1 to infinity. They start with 1. Okay, so to answer this question, what to list them is going to be the bracket. We're going to have 6 and 7. Why 6 and 7? Because it says a natural number more than 5 and less than 8, which means the 5 is not included, nor the 8. And the numbers more than 5 are 6 and 7, but less than 8. So this is my answer with a bracket, 6 and 7. Now look at B. The set of element X such that X is an integer and X is between -3 and 1. But if you notice, the -3 doesn't have, for the -3, the symbol doesn't have the line underneath it, which means the -3 is not included. And where the 1 is, X is less than or equal to 1, the 1 is included. So the answer is going to be from -2 to 1, all the integers. That's your answer right here. Okay, now here's what you need to know. Whole numbers go from 0 all the way to infinity. And counting numbers are also natural numbers. They begin with 1 and go all the way to infinity. That's something that's key, because if you don't know what they are, you're not going to be able to answer those particular questions. Okay, now this is something from the homework. Okay, exactly from the homework. Here you have to state whether each statement is true or false. Okay, number 1. 3 is an element of the set 2, 5, 7, 9, and 10. This is false because 3 is not in the set. And here's the explanation. 3 is not an element of the set. Number 2. 2 is an element of the set 2, 5, 7, 9, and 10. This is true because 2 is in the set of 2, 5, 7, 9, and 10. So this is true. Okay. Number 3. 6 is not an element of the set containing 1, 3, 5, 7, 9. This is also true because 6 is not in the set. Number 4. 4 is not an element of the set containing 2, 4, 6, 8. This is false because 4 is in the set containing 2, 4, 6, 8. Number 5. The set containing 1, 2, 3, 4 is equal to the set containing the elements 4, 2, 3, 1. This is true because every element in the first set is also on the second set. This is true. These are called equal sets. Number 6. The set containing the elements A, B, C is equal to the set containing the elements A, B, C, D. This is false because the first set doesn't have an element of D. Number 7. The set all the whole numbers greater than 5 and less than 9. Is this true or false? Right? Whole numbers. So whole numbers start with 0. So greater than 5, which is 6, 7, 8, and less than 9, this is true. Okay? And here's in red is always the explanation why. Number 8, all the natural numbers not greater than 4. Remember, all the natural numbers. This has to be false. Why? Because 0 is not a natural number. Number 9, the set of elements x such that x is an even integer and x is between 5 and 19, including 5 and including 19. Let's see, so even integers will be the 6, the 8, the 10, 12, 14, 16, and this is false. Why? Because the 18 is missing. Number 10, the set of elements x such that x is a vowel. This is true because all the vowels are A, E, I, O, U. That's true. The list is all the vowels. Now these are some from the homework, exactly the way they are there, but maybe they'll be a little bit. The concept is there, but maybe they'll be a little bit different. But that's from the homework. Now these are more definitions that you gotta know. The universal set is a set that contains all of the objects being discussed. Okay, subset and proper subsets. A set A, right, which is in green, is a subset of a set B. This is the way you write it, written in the A, right, with a symbol. That means subset. It's a subset of B, and here's why. Here's the condition why. Provided that every element of A is also an element of B. And this, students, you can actually put in an index card, so when you do some of the homework, you know exactly what the meaning is. Now the second one here, a set A is a proper subset of set B, and here's how you write it. The difference between a subset and a proper subset is the symbol, the little line underneath it, which is, the little line is a difference between them two. But it has a different meaning. A is a proper subset if every element of A is an element of B, but B contains at least one element that is not in A, that is not a member of A. And here the last one, when A contains an element that is not in B, then A is not a subset of B. And we write it as A, not a subset of B. Okay, now let's put those, here's one more definition. For any set A, the empty set is always a proper subset and a subset of A. And also A is a subset of itself. Every set is a subset of itself. Here's where it's crucial to put everything, to put all these in an index card. Okay? Now here's the examples. Let me go back real quick. Okay, now these are all true here, guys, okay? For example, A is a subset of B. Why? Because every set in A, the elements A, B, and C are also in set B, which is A, B, and C. That's why A is considered a subset of B. Now look at B. The symbol means proper subset. Every element of A is an element of B, right? This is the reason why. If you notice, every element in A, which is A, B, and C, is also in B, which is A, B, C, and D, right? And here's here's the definition why. If every element of A is an element of B, which is true, right? A, B, C is also in set B, A, B, C, D. But B contains at least one element that is not an A, which in this case is going to be my D. Okay. Now C now. Set B is not a proper subset of A. Right? Here it is because set B, right? We have A, B, C, and D. If we notice, every element on set B is not every element in set A because the D is missing. Okay. Now look at D. D is A is a subset of C. Let's look at them. You see, set A has the elements of A, B, and C, and set C has the elements of C, A, and B. So this is true, right? It's a subset because every element in A is also in C. That's why this statement holds. Now let's do E. A is not a proper subset of B. This is correct, right? Because here's the definition again. For a proper subset, every element of A is an element of B, but B contains at least one element not in A. In this case, A is not a proper subset, right? Because every element of A is in C, right? But C does not contain an extra element. That's why. And F is the definition here. Every set has an empty set. You see, this is a definition here. For any set A, the empty set is always a proper subset and a subset of A. That's why F is true according to his definition here. Okay, now, this is also straight from the homework. Okay, they're going to give you set A, which is -404, set B, which is the integers from -3 to 3, set C is -4, -104, and set D, which has 0, set E, which is -4, and this is a universal set. Goes from -4 to +4, all the integers. So this is number 11. It says A, right? So we have to put the proper subset or not a subset. Let's look at A and U. We notice in A has the elements -4, 0, and 4. And U, we have the elements from -4 to 4, right? So the -4 is there, the 0 is there, and the 4 is there, right? So all these elements are also in U. So the first symbol, the one in red, goes there. And there's the reason why. Okay, now, number 12. Let's look at E. E is a set with elements of -4. Let's look at A. A has the elements -4, 0, and 4. So again, on this one, the first symbol is the one that goes, the one in red. And for the very same reason. Okay. Now let's reverse it. Instead of E first and then A, let's put A first and then E. So set A is -404, and set E is just -4. So this will be the second symbol, because every element of A is not an element of E. That'll be the second symbol. Number 14, we have B and we have C. Oh, my bad. Here. So here, guys, is going to be this other symbol because every element in B is not in C. Okay, so that's why the second symbol goes. For 15, this will be the first symbol, which is a proper subset. Why? Because remember the definition? Every empty set is a proper subset of any set. Number 16, we have the set containing 0 and 1. Now let's look at D. D has the element only of 0. So this will be the second symbol, which will be not a subset. Okay, and there's the explanation why. Now for 17, all we did is reverse 16, right? Now D is first, and then the set with 0, 1 is second. This will be, let me see, D has a symbol of 0. So this will be the first symbol because the 0 is in the set containing the elements 0 and 1. Number 18, we have D, right, and B. So this is my D, which is a set containing 0, and B is a set containing the integers from -3 to 3. So this will be the first symbol, which is a proper subset, because every element of D is an element of A. Okay. Now 19, we have set A, which is the elements -404, and we have set C, the elements -4, -1, 0, and 4. So this will be the first symbol, right? Because A is a proper subset of C, because every element in A is also in C, and C contains another element, which is a -1. Okay. And again, this is straight up the homework. Now here, subsets. Here they want you to list all the possible subsets for each of the given sets. Okay. Recall. Set A is a subset of set B, right? Written in this form. A is a subset of B, provided that every element of A is also an element of B. Solution, right? Remember, we start with the empty set. The empty set is always a subset of any set. Now, let's take it one at a time. The set containing 4 is also a subset of the set 4, 6, right? Because 4 is in 4, 6. And then it's going to be the 6, right? And then now we do it in pairs. So it's going to be the set containing 4 and 6 is a subset of the set containing 4 and 6. So here are my answers. We have 1, 2, 3, 4. And this is the answer because I want you to list them. That's my answer. Now, here, the set with 2 elements has 4 subsets. Now let's try B. Right? So we started with the empty set. And then we're going to get it one at a time. Just do the set containing A is also a subset of the set containing A, B, and C. Then it's going to be B and C. Now let's do them in pairs. Let's going to put AB, right? The element AB is also a subset of the set containing A, B, and C. And then we're going to put AC and then BC. That's the only way it can be with 2 elements. Now, the last one is every set is a subset of itself. So the answer, there's my answer, there's a list. If you notice, a set with 3 elements has 8 subsets. There has to be a pattern here. And here's your pattern. Say a set contains n distinct elements. For example, here, right, there were 2 elements. So it's going to be 2 to the 4th power, 2 to the 2nd power, that's why there's 4. On example B, right, we have n is equal to 3 because there's 3 elements, so n is 3. So how many subsets will there be? It will be 2 to the n power, so it's going to be 2 to the 3rd power is equal to 8. That's why we have 8. Okay, now, you have to be real careful here, right? Because if they say to list them, you have to list them the way we did the examples A and B. But if they're asking only for the number, we use the formula here. So number 20, right? We only have 1 element, so it's going to be 2 to the 1st power. That's why the answer is 2. For 21, there's going to be 3 elements, so it's going to be 2 to the 3rd power. It's going to have a total of 8 subsets. So number 22, remember it's a whole number, less than 5. So whole numbers start with 0 and go all the way to 4. So there's going to be 1, 2, 3, 4, 5 elements. So it's going to be 2 to the 5th power is equal to 32 subsets. Okay? Now, these are called operation on sets. Say you're given a set A and a universal set U. The set of elements of U that do not belong in A is called the complement of A. The complement of A is written in the form A prime. Or you can say not A. Let me show an example here. The universal set, which are all the numbers being considered, they go from 1 to 12. And set A, which are the numbers from 1 to 4. Okay, now, this is called a Venn diagram. Okay? This is the universal set because only this and the rectangle are the ones that are included. That's the universal set. Now, this is set A, and the outside will be not A, or the complement of A. That represents here with a concept. Now, with the example, let's put it to practice. Find the complement of A. I like to tell my students that you can say A prime or the complement of A, but there's another way that I can explain it. I call it not A. So not A means that I'm going to go to my universal set. So it's going to be not 1, right? Because 1's here, not 2, cross it out, not 3, and not 4. So whatever left is my answer for the complement of A or A prime. There's your answer. Right? Because 5, 6, 7, 8, 9, 10, 11, 12 was what's left. So this is considered not A or the complement of A. Now, how can we represent it in a Venn diagram? Okay, it's going to be the same as a previous example, but with the actual elements. That's my universal set. But A, what's in A? 1, 2, 3, 4. Right? That's my set A. Okay, hold on. And then the complement, right? So this is A, right? So not A will be in the outside. That's why all these will be in the outside. They're not in A, but they're in the universal set. You see, this is A, and this is not A, or the complement of A. Now, this is called intersection of two sets, which is called the AND. And, okay, given two sets, A and B, the set of elements belonging to both set A and B is called the intersection of the two sets. And this is how you write it. A with the upside down U, right? This means intersection. Elements belonging to both sets. But I like to say it another way for students to understand it. What do they have in common? This makes more sense to the students. What do they have in common? What do both sets have in common? Example. Again, we have the universal set from 1 to 12. Then set A is 1 through 4. And set B is 2, 4, 6, 8. Okay, now find A intersects B. What does set A and B have in common? Do they have a 1 in common? No. Do they have a 2? Yes. Do they have a 3? No. A 4? Yes. Well, guess what? That's my answer. The set contains the elements 2 and 4 because that's what both sets have in common. Okay, now how do we represent that in the Venn diagram? That's my universal set. Here in the middle is where they intersect. That's set A, and this is set B, and this is the intersection of A and B. Okay, now how do we list the elements in the Venn diagram? Right, this is set U. So we're going to start here, right? The 2 and the 4 go here because that's what they have in common. Now we're going to go to set A. Set A has the elements 1, 2, 3, 4, right? So 2 and 4 are already here. So 1 goes there in the circle. That's set A. 1 goes there, and 3 goes here, right? Because set A is a whole set. It contains the elements 1, 2, 3, 4. Now for set B, right? The 2 and the 4 are already here. So it's going to be 6 and 8. So this is how you represent A intersects B. But guess what? Well, you're missing some of the elements, right? We have the 1, the 2, the 3, the 4. The 5 is missing, so the 5 goes inside the universal set, but outside A and B. We have 5, we have 6, so we need the 7. We got the 8, we need 9, we need 10, we need 11, we need 12. This is how you represent this problem in a Venn diagram. Now this is called disjointed sets. It says for any set A and C, if A and C are disjointed sets, then the intersection is an empty set. This means that the set A and C, they don't have nothing in common. They don't intersect. They're disjointed or they're just separate. Okay, here's the example. Again, we have the same universal set, the same set A, the same set B, but we added the set C, which is 5, 7, 9, 11. Okay, find A intersects C, right? What does A and C have in common? We have a 1, 2, 3, 4. The 1, 2, 3, 4 are not in C, so it's going to be the empty set. Nothing. So that's my answer is the empty set. Okay, now how do we represent it with a Venn diagram? This is the universal set. That's set A, and over here is set C, right? They don't have nothing in common. This means that they're disjointed. They're not jointed. They're disjointed. Okay, now let's do the situation here in a Venn diagram. This is my universal set. Set A contains the elements 1, 2, 3, 4. And set C contains the elements 5, 7, 9, 11. Now, what goes in the outside of the two sets, but inside the universal set? We have 1, 2, 3, 4, 5. The 6 is missing. 7, 8. The 8 is missing. We got the 9. The 10 is missing. And the 12 is missing. That's how you represent this problem in a Venn diagram. Now, this is called the union of two sets, or the OR. Given two sets, A and B, the set of elements belonging to set A or B is called the union of the two sets. And this is how you write it, A union B. But here's the way I like to say it to the students in red. You're going to list all the elements of both sets, but do not repeat the elements. Okay? Example. We have the same as before. The universal set the same. Set A and set B are the same. So let's do A union B. So here's how I tell my students. First, since A is first, I'm going to put all the elements of A, which is 1, 2, 3, 4. Then I'm going to go to B, right, which is over here. If the element is already in there, you don't write it again. Is a 2 already there? Yes. So we don't put it again. Is a 6 already there? No. So we got to add 6. Is the 8 already there? No. So we're going to add 8. This is my solution. Again, you're going to put them all down, but you don't repeat them. Now here's how you represent this in a Venn diagram. That's universal set. This is set A. Set B. This is the intersection. Right? So the union will be all this right here. All this will be union. Okay, now let's put it here. Set A, right? Which is 1. The 2 goes here in the middle. The 3 goes there. The 4 goes in the middle because that's what they have in common. Now we go to set B, right? This is set B over here. Set B has 2, 4, 6, 8. So we got the 2, we got the 4, we need the 6, and we need the 8. That's how we represent A union B, which means all this right here. But then on the outside, right, that are not in A union B, we got the 1, 2, 3, 4, the 5 is missing, the 7 is missing, we got the 8, the 9 is missing, the 10, the 11, and the 12. This is your solution, guys. Let me go back real quick. Again, that's your answer right there. Okay, now we have operation on sets. Let A and B be any set, with U signifying the universal set. Then the complement of A is written in this form. Right? This is the way you write it. The complement of A is a set of elements X such that X is not an element of A and X is an element of U. That means that's what we represent, not A. And here's a graph, a Venn diagram with shading, right? So here they're going to want you to shade the correct answer here, guys. So not A means all this right here, not an A. Now we're going to do the intersection of A and B. Right, this is how you say it. The intersection of A and B is equal to the set of elements X such that X is an element of A and X is an element of B. The word and means that they both are in there. And this is how you shade it, right in the middle. That's the answer for A intersects B, right here. Okay, for the union, again, that's a vocabulary, how you say it, but the union will be all set A and B. All this should be shaded. And here's how you say it. The set, right? The set of X elements such that X is an element of A or X is an element of B or both. And this is how you shape that one. Now this will be this also is from the homework. Okay, they give you the universal set, which is A, B, C, D, E, 1, 2, 3, 4, 5. And then they give you the set X, which is AB, 1, 2, 3, the set Y, BD, 1, 3, 5, and the set Z, which is B, 2, 3. So you notice this is number 23. They want you to find the intersection of X and Y. But before we start doing all this, I'm going to find the complement of x, the complement of y, because we're going to need them. So there's a 6, right? The complement of x or not x, then you have to go to the universal set, which means not A, not B, not C, not 1, 2, 3, not A, not B, not C, not 1, 2, 3. So the answer will be D, E, 4, 5. Or C, D, E, 4, 5, because C is also not in X. This is my set Y. So the complement of Y will be AC, E2, 4. Why? Because the complement of Y means not B. You go to Y, not B, not D, not 1, not 3, not 5, which is, this will be left. Not B, not D, we're left with A and C. Not 1, 3, 5, we're left with E, and 2 and 4. That's the answer for that one. And for Z, right? For Z, do we have to find the complement of Z? No, we don't. So that's all we need, for these right here. So 23. Find the intersection of X and Y. Again, what does X and Y have in common? Okay, let's go here to the right. The X and Y have in common, they have in common a B, they have in common 1 and 3. And that's it. That's your answer. Number 24. X union Y. Remember how I told you to do it? So we're going to put everything that's in X, which is A, B, 1, 2, 3. Now we're going to go to Y. If the element is already in the set, we don't write it again. Is the B there already? Yes, so we don't write it again. How about the D? No, so we have to put the D in there. The 1 is already there. The 3 is already there. The 5, no, it's not, so let's put the 5. And that's my answer. And now if you want, you can put them in order. But you don't have to, because these are considered equal sets. So the order does not matter, but if you check the answer in the back of the book or the response in MyMathLab, they're going to give it to you in order, alphabetical order, and from least to greatest on the numbers. Now for number 25, right, the complement of X, we already got the answer here on the right. So that's your answer, C, D, E, 4, 5. Number 26, the complement of X intersects the complement of Y. So in other words, what does the complement of X and the complement of Y have in common? Let's go here on the right side. They have in common C and E and the 4. That's your answer. Now for number 27, we have the complement of X. It's over here on the right. What does X prime or the complement of X and Z have in common? Do they have a B? No. A 2? No. A 3? No. So that's going to be the empty set, right? This means empty set. Now for number 28, you have X union parentheses Y intersects Z. So here, guys, again, you're going to have to follow PEMDAS, which order of operation. So first, we have to do parentheses. So what does Y and Z have in common? Y and Z, right? That's what the symbol means. What they intersect or what they have in common. They have in common a B, right? A B and a 3. And that's it. So Y intersects Z is a set containing the elements B and 3. Now, this means right union. Remember that a union means that you're going to write them all down, but you don't repeat them. So what I do, I'm going to go to set X, and I'm going to put A, B, 1, 2, 3 first, because that's set X. Then I'm going to go to the other set, to the set containing B and 3. If the B and 3 are already in the set, we don't write them again. Is the B there? Yes, it is. It's here, right? Is the 3 there? Yes, it is. That's there. So this is your solution. The set containing the elements A, B, 1, 2, 3. Now, Venn diagram with 3 sets. Okay, now here, guys, they want you to list the universal set, set A, set B, set C, the intersection of A and B, the intersection of A and C, the intersection of B and C, and the intersection of all 3, A, B, and C. So universal set, these are all the elements. So it's going to be A A, B, C, D, E, F, G. That's my answer for the universal set. Now for set A, let's call this set A here. Set A is going to be A, B, E, G. Set B is going to be B, D, F, G. All this is set B. For set C, we have C, E, F, G. That's my answer. Okay, now, intersection of A and B. So this is set A, and this is set B. Where do they intersect, or what do they have in common? The answer will be D and G. Now comes the intersection of A and C. Again, this is set A, and this is set C. So the intersection is this portion of where the two graphs intersect. It's going to be E and G. And where does B and C intersect? Again, this is set B, and this is set C. So they intersect here in this portion here, so it's going to be FG. Now, lastly, where do the all three sets intersect? The answer will be G. Here's where all three intersect. The answer is the set containing the element G. Okay, now this, I'd like to give the students this on their exam or also for extra credit. Okay, so let me show you how you construct something like this. This is actually from the homework. It says 60 people were contracted and responded to a movie survey. The following information was obtained. It says 6 people like comedies, dramas, and science fiction. 13 people like comedies and dramas. 10 people like comedies and science fiction. 11 people like dramas and science fiction. 26 people like comedies. 21 people like dramas. And 25 people like science fiction. Then you have to answer the questions A, B, C, and D. Okay, so how are we going to do it? For part A, I want you to construct a Venn diagram. So first, right, is my universal set, which is 60. Right? Hey guys, so here, that's why I put it in red here. Here in red is where you always start when they give you a problem like this one here, like number 30. You always start where all three have in common, right? Because that's what it means. They like comedies, dramas, and science fiction. So that means what all three sets have in common. So I'm going to let C be comedies. I'm going to let D be dramas. So this is set D, and I'm going to let S be science fiction. So right, this is for the first one where it says 6 people like comedies, dramas, and science fiction, which translate to what all 6 sets have in common, which is 6. So what they have in common will be this little section here. That's going to be my 6. Then you're going to go to the second here where it says 13 people like comedies and dramas. So we're looking for where set C and set D intersect. Again, this is set C, and this is set D. So where they intersect will be this section here. Since we already have 6, so this section here has to be 7, because 6 plus 7 will give you the 13. Now, we're doing set C intersection set S, so it's going to be these two sets here. So here's where they intersect this section here. So it's got to be 10, right? So we already have a 6, so this has to be 4. Now comes D intersects S, which will be, D and S will be these two sets here, which is 11. So the intersection will be this portion here. Has to be 11, right? We already have 6, so we need 5 more. So that'll be 5. Now we're going to go to set C. On set C, right, which means this whole set, there's supposed to be 26. Since I already got 4 and 6 and 7, which is 17, so we subtract 17 minus 26, which will give you 9. Now we're going to do set D, right, which people that like dramas, which is 21. This is my set D here. I already have 7 and 6 is 13, plus 5 is 18. So all this has to be 21, right? So we already have 18. So what's missing will be this portion here, which is 3. And also, set S, right? Set S is going to be 25 people. So we already got all this is set S here. Okay, where I'm doing the circle with my mouse. We got 4 and 6 is 10 plus 5 is 15. So if all this set must be 25, we already got 15. So 10 goes here. Now, what's still missing? Right, there's supposed to be 60, right? Let's see how many all these are. So we have to solve how many are not in C and set C, D, or S. So we're going to add all these numbers up, right, which is equal to 44. We subtract that from 60 to see how many are not in the sets, but they're in the universal set. So the answer is 16. Now let's go and answer the questions. It says use a Venn diagram to illustrate the survey's result. Right, I already did that. I already did part A. Now let's do part B. It says how many people surveyed like comedies, right? So comedies, so they're talking about all this section here. They like comedies. But neither dramas nor science fiction. They like comedies, but they didn't like these right here. So the answer will be 9. Now part C. How many people surveyed like dramas and science fiction, but not comedies? So let's go to dramas, right? Dramas and science fiction, right? So this is dramas here, and this is science fiction. They like these two, right? But they didn't like comedies. So it'll be not these, right? So I can cover all these because these are comedies. So then the answer will be 10 plus 5 plus 3, which is 18. And for part D, how many people like none of the movie styles? So the answer is 16, right? They were part of the 60, but those didn't like the movies. So the answer will be 16. Okay. And that's how you do these type of problems, guys. But the main thing here that you got to remember, when you start, you always start where all 3 sets intersect. Okay. Now we're doing, this is something from 8.3, not 8.2. Introduction to probabilities. A random experiment, a process by which we observe something uncertain. After the experiment, the result of the random experiment is known. Denoted by, this means sample space, denoted by S is a sample space. For example, let's do examples of sample space. For a coin flipping, right? For a coin flipping, the sample space would just be heads or tails, right? Because if you flip one coin, it can either be heads or tails. Rolling a fair die. The sample space will be a 1, 2, 3, 4, 5, 6, because when you roll a die, it can only be from 1 through 6. That's it. And the fair die means that all the sides are equal weight, because if they're loaded dice, it means that when you roll it, it will always go to a specific number because the dice are not fair. So fair means that they're all right. They're all weigh the same. Every side weighs the same. Now find the sample space of an experiment, right? We want the sample space. At times, it is easier to draw a tree. Okay, for example, find the sample space of flipping a coin twice, right? So if we flip it, what can it be? It can be heads, right? Or it can be tails. That's your first flip. The second flip, right? Say you got heads first, so the second flip, it can be heads, and then you can get heads or tails again. But say you got tails the first try, then you can get tails, and then you can get heads or tails again. So a sample space will be HH, HT, TH, and TT. That's your sample space, right? S is equal to the set containing HH, HT, TH, and TT. This is considered my sample space. Now, an event. An event is an outcome or a set of outcomes of a random experiment. An event is a subset of the sample space. Okay, now, for example, if the sample space for flipping a coin is S equals H or T, then one event can be the H, flipping a heads, which represents the outcome of heads, right? Because H is a subset of the sample space, right? H is a subset of HT. That's what it means here. Checkpoint. Suppose the die is tossed. Write the given events in notation. Okay. The number is showing is less than 3. So it's going to be, right? So this is my sample space, right? So for the event, it's going to be 1 and 2. And the number showing is less than 3. 1 and 2 is my answer. The set containing the elements 1 and 2. Now let's do B. The number is showing is a 5, so it's going to be only 5. The set containing the element 5. Now C. The number showing is an 8. There's going to be the empty set, right? Because there's no way, because if the numbers are from 1 to 6, the 8 is not there, so it's going to be the empty set. Now D. The number showing is even, right? So it's going to be the even numbers will be 2, 4, and 6. It'll be the set containing the elements 2, 4, and 6. This is the event. Now comes the probability. The probability of an event is equal to N of E, which means the number of the event over the number of the sample space. Example. Okay, here it is. That's what I mentioned right now. Checkpoint. See here, suppose a single fair die is rolled with the samples, right? This is my sample space. A equals to 1, 2, 3, 4, 5, 6. Give the probability of each of the following events. A die shows an even number, right? Even number means 2, 4, 6, right? Which is 3 elements. So it's going to be the probability of an even number is going to be 3 over 6, which is a 1/2. A die shows a number less than 10. So, right, it is in my sample space, so it's going to be all 6, because a number less than 10 will be the 1 through 6. So it's going to be 6 over 6, which is 1. And see, a die shows an 8, right? This will be, right, 0. No number shows an 8, so it's going to be 0 over 6, which will give us 0. So there's no chance you're going to get an 8. Now, a single playing card is drawn at random from an ordinary 52-yard card deck. Find the probability of drawing a queen, a diamond, a red card, and a face card or an ace. I just did this presentation for my 1324 class, and I was amazed that some students have never played cards. So some of the young students. If you're old as I am, like 62, you know what cards are, right? But for some young students, they never play cards because they were never exposed to them. So anyway, they might be confused to answer some of these questions. So what I did, I actually put them there so you guys can have a visual of what they mean. Right? These are going to be, there's 52 playing cards total. But in reality, there's 54 because there's 2 jokers. But in this case, they don't want to count the jokers, just 52. These are the clubs or the clovers. There's 13 of each one. There's 13 spades, 13 hearts, and 13 diamonds. They go from the ace, which is like a 1, right? They go from the ace all the way to 10 plus 3 face cards, the jack, queen, and king. There's my total 52. Now, there's 26 black cards and 26 red cards. There's going to be 3 face cards. For a long time, I didn't know they were called face cards, right? In a way, I was playing cards back when I was young, but these are the face cards, right? It has a face on the card. If you notice, there's going to be 12 because there's 3 on each suit. There's a jack, queen, king for every suit, which will be 3 times 4 is 12. Now, let's answer the questions here. Right, we have to know that the sample space will always be 52. So the probability of a queen is going to be 4, right? Because there's 4 queens over 52. The answer is 1 over 13. You have to reduce it. A diamond. There's 13 diamonds, right? They're all here, the diamonds. 13 over 52, the answer will be 1/4. A red card, right? We know there's 26 black and 26 red, so the answer is going to be 26 over 52. The answer is going to be 1/2. A face card or an ace, right? So a face card is going to be 12 face cards plus 4 aces divided by 52. It's going to be 16 over 52. It's going to be 4 over 13. That's how you answer some of these questions here. Now, find the probability the sum is less than 4. So this is all the combinations, right, for the dice. It says here, an experiment consisting of rolling fair dice and adding the dots on the two sides of facing up. So find the probability the sum is less than 4. So the sample space will be 36, right, because there's 6 times 6 is 36. For less than 4, right, so it's going to be, this is less than 4, and that's less than 4. So it's going to be 3 over 52. I mean, 36, I'm sorry, I was thinking about the cards. So the answer will be 1 over 12. Number 11, find the probability the sum is not 7 or 11. Right, so these are the 7, the sum. So not the 7s, nor 11. Right, which will be, not 7 or 11 will be the 6 plus 2, right, which will be 8. So, but instead of counting all these, right, so if it says not these, which means it's going to be everything else, so the easier way is to subtract 8 from 36, right, which would be 28 over 36. Or you can go like this, count them all, 1, 2, 3, 4, see, and so forth. That's going to be too long. But you can do it both ways. But if you do it like this, right, not these, not the 7 or 11, so it's going to be everything else. And everything else is going to be 8. 36 minus 8, which will give us 28. We reduce it. The answer is 7 over 9. Now, here, let the universal set U be the set of 120 students in a class. A, the set of students from the class of arts and science. So A means arts and science. B is for business. F is for freshman, and S is for sophomore. There's the arts and science. There's the business, the freshman, and the sophomore. This is also from the homework. I tell my students to add them all. For arts and science, right? We add them across. Okay, so let's start here. No, but that's the best way is to add them across, guys, first, and then get the answer. But here, guys, I didn't do that here. So here, what I'm going to do, I'm going to add all the sophomores, which is 35. So that's my answer. Now for find the number of B, the number of business is going to be 66 plus 21, which would be 87. Find and, right, the number of B intersects S, right? So it's going to be B intersects S will be 21. That's my answer. Now find the union of B, union S, right? We can do it two ways. This is B, right? B is 87, right? I already count these. And then S will be this right here, right? But I already counted the 21 here across. So it's going to be 87 plus 14. Or we can use this formula here. There's a formula to find the union, right? It's going to be the number of A plus the number of B minus the number of where they intersect. So the number of A, right? So here, guys, right? So, but we're talking about business and business and sophomores. So number of business will be 87. The number of S of sophomores will be 35. Where they intersect will be 21. So the answer will be 87 plus 14, which is 101. Or you can do it without the formula, right? Again, if it says the number of business union S, right? So business will be 87 and the sophomores will be 35, right? But the 21, you don't count it again because it's already been counting. It's already been counted. So it's going to be the 87 plus the 14, which is the same thing as 101. Okay. Now, I believe this will be the last example that I'm going to cover because it's already 12. Okay, now there's an example from 8.4. And then after this one, we'll stop there. And I believe for next week, I continue with the last two slides that I'm going to, that are here, but I'm going to do them next week instead. Okay, because I always like to overlap it when we get to the sections, just in case for some of the students they're not actually joined, I can explain it again. Example 1, when playing American roulette, the croupier, which is the attendant, spins a marble that lands in one of 38 slots in a revolving turntable. The slots are numbered 1 through 36, with 2 additional slots labeled 00 that are painted green, right? These are the 00, which are 00 and 0, which are green. Have or they're supposed to be off here, but I put or half of the remaining slots are colored red or black, red and black. In roulette, a slot labeled 00 is not considered even or odd. Now here we go. Find the probability that the marble will land on a red or an even. Okay, so solution. Here we go. We're going to let the set of red be R. This is all the red, right? So I went all on the example, and these are all the red numbers. Now we're going to let the set of even be E. So, right, so the evens are, I mean, I went around the roulette table and I put all the even numbers. Now, so here's the probability, right? So the probability of red is going to be 26. 26, right? So here, because there's going to be 18, because there's 18 red and 18 black. So the probability of red is going to be 18 over 36. Okay, here we go. The probability of even is also going to be 18 over 36. I mean, over 38, I'm sorry. I'm thinking about the dice. Now, where does the red and the even intersect, or what they have in common, will be 1, 2, 3, 4, 5, 6, 7, 8. It'll be minus 8 over 38. So the answer will be 28 over 38, guys. Reduce it, will give us 14 over 19. Okay, so let's stop there, guys, and we'll continue again next Friday. Thank you.
Thank you, Mr. Zassi. You ready to take over, Hema?
Yes, I am. Thank you so much, Mrs. Jassi, for your presentation.
Thank you.
We do want to remind everybody about the previously recorded sessions, which are available on a YouTube playlist. The session will also be available on that playlist later today. Also linked is a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey. And before you all leave, I want to share the TV sessions that we'll have next. So at 1 p.m. today, we will have a presentation on the Pulse Radio and Eureka Club. And we will be back with Happy Math Hour next week at 11 a.m., where Math 1314 will cover inverses and determinants of matrices, and Math 1324 will cover concepts of probability, permutations, and combinations. Our 1 p.m. session next week will be a presentation with the EPCC Mental Health Committee. Thank you for coming in today. We hope you all have a lovely weekend. We hope to see everyone again for Happy Math Hour.